that's 2 to the I plus 1, which is the double amount, and taking away the original amount, which is half of it. Okay? So that creates from one exponential a difference of exponential. And so what we're going to do is, when we have this, it's a summation of this whole thing, but this is really I times 2 to the I plus 1 minus I times 2 to the I. So when I do that, I have two terms in here. And each of those terms is being affected by the summation. So it's a summation of I 2 to the I plus 1 minus the summation of I 2 to the I. And there it is. So it's the first summation, I 2 to the I plus 1, minus the summation of I 2 to the I. Notice the indexes are following 1 to k, 1 to k. So that's cool, because I see a difference and I see some similarity here, but these are not quite the same. I have I to the 2i plus 1, this is 2 to the I, so they're a little bit different from each other. So what I'm going to do is I'm going to try to make these exponents the same. I am not going to touch this term at all. I'm going to leave this summation alone. But what I'm going to do is I'm going to take the bottom index, 1, and I'm going to bring it down to 0. If I bring the index down to 0 and the upper down to k minus 1, I'm reducing the value of I every single term. So in order to balance the equation back to what it was, I will increase the usage of the index by 1. So when I decrease I to I from 1 to 0, I will increase its usage to I plus 1. Notice that when I is 0, this is 1. Notice that when I is 1, this is 1. Notice that when I is 0, this is 2 to the 1. Notice when I is 1, this is 2 to the 1. So we've changed the indexing. We've lowered the index by 1, but we increased its usage by 1. So the equation still is producing the same terms. But the cool thing about it now is that I have I 2 to the I plus 1, 2 to the I plus 1 again. That's the good news. The bad news is that I now have two terms here, which means that I have to multiply this by this and this by that. So I'll produce two more summations inside the minus. So the first summation stays unaffected. Notice it's minus all of this. So therefore, when I multiply it out, it's going to be minus the first product summation minus the second product summation. So the first is unaffected, minus I 2 to the I plus 1 minus 1 times 2 to the I plus 1. So we go from here to here. And then watch these signs. Make sure that they are what they're supposed to be. Any questions about that so far? So now what we're going to do, now we have this, we're going to now see what we've been trying to get. Notice that now we have this term is exactly the same as this term. The only thing different is the index is 1 to k, 0 to k minus 1. What is the same in both of them? They both have a what? Bottom. They both have a what at the bottom? 1. 1. So that means the 1 maps to this 1. And what do they have the same on top? They both end at k minus 1. So the only thing that's not going to get subtracted is the k from this term and the 0 from this term. The 0 from this term will be 0. Why? Because it's 0 times whatever. So the only thing remaining from these two summations will be when I is equal to k, this is going to be k times 2 and k plus 1. So this is the only remaining thing for the difference. Because the other one is 0. Now what is this? This is this, and this is this. And this is that little 0 thing here. And finally, I have this summation, which is over here. So these are canceling completely. So this is the one term from here, this is the one term from here, and this is the full cancellation. This is the 1 through k minus 1, and then minus each other. Finally, we have minus this one, and that's what we have. Now, so this is simple. These guys have canceled each other completely. This is 0. The only thing we have is here, but this is just a geometric series. And because it's a geometric series, we can solve it right away. Because we know what's the first term. The first term is? The first term is 2, because it's going to be 2 to the 0 plus 1 is 2. How many terms do we have? K. So the first term is 2, right? How many terms? Number of terms is K, and the ratio is 2. So the formula is going to be 2 minus A minus A to the R. Let's do it out here. We're going to have 2 times what? 2 minus A minus A times R, the number of terms, over 1 minus 2, which is going to give me 2 minus 2, the K plus 1, over negative 1, multiply top and bottom by negative 1. We get 2 to the K plus 1 minus 2. So take this, which is the result of this. So we have K times, we have K times 2 to the K plus 1 minus 2. This 2. Yeah, so you see over here, 2 to the K plus 1 minus 2, right? So, K of this minus 1 of these, K minus 1 of this exponential plus 2. Done. Okay? This is, I'm not going to go through this, but this is how you would do the same thing for getting I 3 to the I. More complicated because 3 to the I is not equal to 3 to the I plus 1 minus 3 to the I. It's equal to 3 to the I plus 1 minus twice 3 to the I. Because this one is 3 times bigger than this one, so you have to multiply it by 3 to get 3 times bigger, and subtract 2 of the smaller one to get back to the original. So the idea is, just want to make sure that you understand the key here, is that when we do this right here, to change the index, we set up something known as a telescope, where we have the same terms to almost the same indexes, and they cancel each other out like a little telescope. They just kind of close it. You know what a telescope looks like? You pull it out like this, right? So what happens when you push them? They collapse. So we collapsed all the terms except for 1 for K and 1 for 0. 1 for K, 1 for 0. Telescope. We do the same thing. So in this example, I do the same thing. I get a telescope here, and the same thing happens. You can go through that. Okay, see you Wednesday.